Hey, everybody. So here are our notes examples for accuracy and precision. So in these, we will, at the end, we should be able to identify the precision and uncertainty in a measurement, to be able to calculate the range of values a measurement could be, and be able to add and subtract measurements that have uncertainty. So we have a ruler marked in millimeters used to measure this pencil. Okay, so I want the precision and uncertainty. So I'm going to do precision and uncertainty. Oh man, that's a bad line. Okay, so the precision of this ruler is the smallest unit of measurement. So I do have centimeters here, but that's not as small as I can go. I can go to the nearest millimeter. So the precision is 1 millimeter. So the uncertainty will be half of that. So I take half of my 1 millimeter. So I have 1 millimeter, I divide that by 2 to get 0.5 of a millimeter. Right. In example B, we have an odometer. It records distance traveled to the nearest kilometer. Okay, so the nearest kilometer. So that's my smallest unit of measurement. So 1 kilometer, so measures distance. Now my uncertainty is going to be half of that. Okay, so half of a kilometer. Right. Next example, we have the outside temperature is recorded at 12 degrees Celsius, right? So my smallest, I'm not given uh, the nearest whatever. So I have to take a look at my smallest value. So my smallest value is in the ones place, is my smallest place value. So it's to the nearest 1 degree Celsius. There's my ones. So my uncertainty will be what 1 degree Celsius divided by 2, so half a degree Celsius. And in our last example, we have Dave. He says it took him about 5 hours to drive from Vancouver to Kamloops. Now, this about tells us that we are not going to have a high degree of precision. Okay, so he wasn't really timing it, obviously. So we could have a possible, like, there could be a possible number of answers here. So maybe he was doing it to the nearest hour. Like, so maybe his precision is like 1 hour, in which case his uncertainty would be half an hour. Okay, or maybe it was like to the nearest minute. So about 5 hours. It could be to the nearest minute. I don't know anybody who would say that and have a precision of 1 minute. But if, let's say, Dave did, and so that would be like his uncertainty would be half of a minute. Okay, more likely it was probably his precision was probably around 15 minutes. So most people know from like a quarter of an hour about how much time things take to the nearest 15 minutes. So I would say this is probably what I would give for Dave. So his uncertainty is probably half of 15 minutes. So 7.5 minutes. So a couple different options for D, depending on, what Dave's precision is, like how precise is he measuring his time. Right. Next example, we have Genevieve mixing juice in a jug marked in quarter liters. She finds the amount of juice in the jug to be 2.5 liters. And we are going to write the measurement of juice in the jug in the form of measured value plus or minus the measurement uncertainty. Okay, so she finds the amount of juice in the jug to be 2.5 liters. That is our measured value. So our measured value is 2.5 liters. She has 2.5 liters of juice. Now, there is some uncertainty there. And to find my uncertainty, I need to know what this juice jug is marked in. What's its smallest unit of measurement? And if I read the question here, it is marked in quarter liters. So quarter liters is 0.25 of a liter. So to find out what my uncertainty is, I need to take that quarter liter. 1/4 is 0.25. So we are going to take that 0.25 of a liter. We are going to divide it by 2 to find out what our uncertainty is. So 0.25 divided by 2, and we get 0.125 of a liter. So that's our uncertainty. So we have 2.5 liters, and then plus or minus 0.125 of a liter. So measured value plus or minus my uncertainty right here. And for part B, what is the range of volume in liters that could be in the jug? So in order to find a range, I want to know, all right, well, what's the maximum amount that can be in the jug? And what is the minimum amount that can be in the jug? So to find my maximum, I'm going to take, well, what is my measured amount and what is my uncertainty? So in order to find the maximum amount that could be in there, I think it's about 2.5 liters, but it could be 0.125 liters more. So I take my measured value and I add my uncertainty to it. Okay, so in this case, I have 2.5 liters, and it could be 0.125 liters more. So my maximum amount that is probably in this jug is 2.625 liters. And find the minimum, I do the opposite. So I have my 2.5 liters, but it could be 0.125 liters less. Okay, so I take my measured amount and I subtract my uncertainty. Oh, sorry for my writing. Why are you so bad? Okay, so 2.5 liters minus 0.125 liters, and we get 3, 7, 5 liters. Okay, so my range in volumes, I could have 2.375 liters to 2.625 liters. All right. For our last example, we're going to add and subtract values with uncertainties. So we have Marcy. She's installing sheets of plywood for a subflooring, and the two pieces of plywood are 2.25 meters long and 1.3 meters long. She's using a tape measure that is marked in centimeters. So this gives us our precision. So our precision is marked in centimeters. So our precision is 1 centimeter, so our smallest unit. Now, I want to write the lengths of each sheet of plywood in the form measured value plus or minus its uncertainty. So in order to find uncertainty, I take my precision, I divide it by 2, and I get half of a centimeter, so 0.5 of a centimeter. Now, I want the same units for both, so I either need to change these meter-long sheets of plywood into centimeters or my centimeter uncertainty, sorry, into meters. And I'm going to actually change these into centimeters instead of going the other way around. So that's not too large of a centimeter number. It'll be 225, right? So 100 centimeters, centi, in a meter. So this will be 225 centimeters. Here I'll have 130 centimeters. So my plywood, my two sheets, will be 225 centimeters plus or minus its uncertainty, so half a centimeter. And same thing here. So 130 centimeters plus or minus, and since using the same measuring device, same uncertainty, right? I could also have done it in meters like this, but it looks a lot messier and it's hard to see that this is like half of a centimeter, whereas this is a little bit easier for our minds to deal with. But it honestly doesn't matter which one you choose, either or. Okay, so for example B, what's the total length, including uncertainty, if the two sheets are placed end to end? So I have my one sheet placed next to my second sheet. Now this sheet is 225, but it could be off by a bit. So it could be plus half a centimeter, it could be minus half a centimeter. So there is some uncertainty here as well as this one. So this could be like 225.5, and this could be like 130.5. Or this could be like 129.5 plus 125. So there is some uncertainty in what this length is going to be when they're placed end to end. So in order to add or subtract values with uncertainties, our first step is to add and subtract our measurements. So we're adding in this case, so we're finding the total length, so we're going to be adding these two together. So I'm going to take my 225 centimeters and I'm going to add that to my 130 centimeters to get my 355 centimeters. Okay, and now there are uncertainties in both of these measurements. So this one could be off by like half a centimeter, and then this one could be off by half a centimeter. And no matter what you have, either adding or subtracting, you will always add the uncertainties. So you'll add the uncertainties. Okay, so half a centimeter plus a half a centimeter, I get 1 centimeter. So my total length is 355 centimeters plus or minus 1 centimeter. Okay, so it could be 356 long or it could be 354 long. Right. And last part, C, if Marcy needs to shorten the plywood, she cuts a 30 centimeter cent from the end. What is the new length of this sheet, including the uncertainty? So she took her 2.25 meter or 225 centimeter sheet and cut 30 centimeters off the end. So it was 225 centimeters long. She cut off 30 centimeters from the end. So she's left with 195 centimeters, but there is some uncertainty there. So sure, I took this, but I'm not sure if it was exactly 225 centimeters long. It could be like half a centimeter off either way. And I took off 30 centimeters using the same measuring device. So this one could be off as well. So I took off 30, but there is a margin of error there. There is an uncertainty. So same thing, I will add my uncertainties together since they both could be off. Oh, my rating's just getting worse. And same thing. So one could be 1 centimeter off. So the new plywood sheet is 195 centimeters long, plus or minus 1 centimeter. So it could be 196 centimeters long, or it could be 194 centimeters long, possibly. All right. So in summary, here is this, and you all should be ready to start your assignment. All right. Bye.